Hey guys, today we're going to move on to radicals. We are going to multiply them together. So what we did last time is we reviewed laws of exponents and we reviewed how to simplify radicals. What we're going to do now is move on and we're going to multiply and divide with them. Okay? Okay, in order to multiply and divide radicals together, okay, they must have the same index in order to simplify, which means they have to have the same root number. So square roots, cube roots, fourth roots, that little number on the outside has to be the same thing, okay? Just to remind you, if we have something written like this, where there is no index being written there, remember that is the same thing as a square root. So that's our default. So if no index is written, then the index is 2. All right? So look in here, we have what is the simplest form. We have what is the cube root of 6 times the square root of 2. Well, if you notice, this has a cube root and a square root, so this one we actually can't simplify. Okay? We can't do anything with these. Number 2, they both have a fifth root. Okay, so we can do this. So what does that mean? Well, they both have a fifth root, so my answer has to have a fifth root. And what we do is we just multiply what's inside. So -5 times -2, so this is going to simplify to be the fifth root of 10, because -5 times -2 is 10. Okay, so if their indexes are the same, then you just multiply what's inside, put it together, and then simplify more if it's possible. I can't simplify the fifth root of 10. That just is what it is. All right. Number 3, this is a division problem. We have the square root of 18 over x to the 5th divided by the square root of 2x to the 3rd. So what we do is dividing is last time we broke it up, remember, and we did like the square root of each piece. We can also go backwards. So I can rewrite this as one giant fraction, 18x to the 5th over 2x cubed. And then I can actually simplify the fraction within. So 18 over 2, right, doesn't that simplify to 9? 18 over 2 is 9. And then x to the 5th over x cubed, that's property of exponents. I can subtract. That simplifies to x squared. So that's going to be the same thing as having the square root of 9x squared. So all I did right there was simplify the fraction. I've done nothing with my square root yet. All I've done is reduce and simplify what's under it. Now let's do the actual square root part. Okay, you can even break this up. Square root of 9 and square root of x squared. Well, the square root of 9 is 3, and the square root of x squared is x. So this simplifies to just 3x. Number 4, I have another division problem. They are both cube roots, so I can move forward with this problem. If one was a square root, I would just stop and say I can't do it. Okay, but they both have a cube root. So I'm going to do exactly what I did last time. I'm going to put it all into one fraction first. So we have 162y to the 5th over 3y squared, and this is now all going to be underneath a cube root. Just like last time, I'm going to simplify my fraction. So I have 162 divided by 3. Let's see if that simplifies. It does. It's 54. And y to the 5th over y squared, I subtract that, and that becomes y cubed. So simplifying my fraction, now I have the cube root of 54y to the power of 3. Okay. I can split this up to the cube root of 54 and the cube root of y cubed. So the cube root of 54 means something times itself 3 times gives me 54. If I go into my calculator, math, cube root 54, see how I get a decimal? Okay, so it doesn't always give you a perfect cube. What I am going to do is I'm going to simplify it. See, is there a perfect cube in it? So this is where simplifying radicals comes in. Okay, I can split apart 54 to be 27 times 2. And I did that because the cube root of 27, that's a perfect cube. Okay, that's going to be equal to 3. And then here, the cube root of y cubed, That's a perfect cube, right? Because what times itself is y cubed? It's y. Okay? So when I have my answer, I have 3 and y that is now released from our radical, but the cube root of 2 is still there. So our simplified answer is going to be 3y cubed, and then times this, 3y times the cube root of 2. Okay, so we got to remember how to simplify our radicals. Okay, if that was a little iffy, we are going to have more work with that, so stay with me. All right, number 5, we have the cube root of 128x to the 7th. It's all under one cube root, so what I'm going to do is just try to break it apart. So I'm going to try the cube root of 128. Doesn't work, right? It's a decimal. I can't use that. We're not using decimals. We're going to keep answers in radical form. So let's split apart 128, okay? Maybe the easiest way for you to split it up is to divide it by 2. So if I do that, if I split apart 128, I can split it up. That's the same thing as saying 64 times 2. And then we still have the cube root of x to the 7th over here. There we go. All right, the cube root of 64. Let's see if that works. So math, cube root 64. It does. There is a cube root of 64. It is the number 4. So this equals 4. There is no cube root of 2. Okay, that stays cube root of 2. Now the cube root of x to the 7th. Okay, well, let's think about what that means. That means that I have 1, 2, 3, 4, 5, 6, 7, right? I have 7 x's underneath my radical, okay? The cube root tells me how many of each I need to bring one of them out. So here's 3 x's, so 1 x is going to come out. Here's another 3 x's, so another x gets to come out, but this guy is by himself, so he is going to stay underneath my radical. All right, so let's look at what got brought to the outside of the radical. There was a 4 and there were 2 x's. So that's 4x squared. And underneath my radical, I still have a 2 and an x. So our answer is going to be 4x squared times the cube root of 2x. All right. Number 6. These are both a square root. Okay, so I can move forward. We're multiplying. They both have square roots, so I can move forward. Let's multiply with what we have. So let's do 45 times 35. It gives me 1575. So we're multiplying my like pieces. So I have 1575. All right, x to the 5th times x to the 1st is x to the 6th, right? Y cubed and y to the 4th is y to the 7th. All right, these are all square roots. So let me see if there's a square root of 1575. There's not. Okay, I have a decimal, so that's not going to work for me. So let's try to split it up. I can split it up with what I started off with, 45 times 35, right? And then I can split up 45 to be what? 9 times 5, and 35 can be 7 times 5. I can split 9 up again to be 3 times 3 times 5 times 7 times 5. Okay, a lot of work, but there's a reason for it. We broke it down to as low as we can go. Remember, our index here is a 2. So this time we're looking for pairs of numbers to bring out to the front. So I see I have a pair of 3s that gets to come out to the front. I also have a pair of 5s that's going to come out to the front. But what's left underneath my square root is a 7. Okay, so I still have a 7 underneath the radical. So all of that simplifies to 15 square root 7. That's just the number. Okay, we still got to deal with the x and the y. but that is the number part of it. All right, let's do x to the power of 6. I'm going to change my colors. All right, so x to the power of 6. Okay, we talked about yesterday also we could divide, right? Remember we did the power and the root? We could do 6 divided by 2 to give me x to the power of 3. The reason why I didn't do that over here, okay, because 7 does not divide by 3 evenly. So knowing that, I knew something was going to be left on the inside of the radical. Okay, 7 over 3, isn't that what? So that's 2 groups with 1 left over. That's 2 1/3. So that's why 2 x's got brought out, but one of them got to be left behind. Okay, here I can rewrite that as 6 over 2. And that's great because it works out. 6 divided by 2 is 3. So I have an x to a power of 3, and it's outside the radical. Okay. The last one, y to the 7th. Again, if I rewrite this as 7 divided by 2, because there is a 2 right here, that does not simplify. So if I look at this, so 7 y's, 1, 2, 3, 4, 5, 6, 7. If my index is 2, we're looking for groups of 2 to leave the radical. So here's a group of 2. Here's another one. Here's another one, right? I'm going to do this. There's a group, here's a group, and here's a group, okay? But I do have a y still left inside my square root. So here, 3 y's got to come out, but there's just 1 left inside. Okay, so to write my answer, we put all the pieces that were outside of my radical together. So 15 is not in a radical, x cubed is not in a radical, and y cubed is not in a radical. But still inside is my 7 and my y. So our answer is going to be 15, x to the power of 3, y to the power of 3, times the square root of what's still in there, 7 times y. Right? All right, number 7, we are going to divide. Again, just like last time we were dividing, we can make this one big old fraction, so I am going to do that. 54 divided by 2 is 27. x5 over x squared gives me x cubed. Y to the power of 3 divided by y to the power of 1 leaves me with the y squared. Okay? It's a square root. My index is 2. So now we got to split things up. So 27, there is no square root of 27. Okay? I have to split it up and try to find one. So 27 can be broken apart to be what? 9 times 3. And then 9 can be broken apart to be 3 times 3. Remember, our index is 2, so we're looking for a pair of numbers, which is, there's a pair of 3's. So the 3 gets to come out, but this one is still inside my square root. Okay, so that's part of my answer. Now I'm going to deal with the x cubed. Okay, remember our index is 2, so I could write it as 3 over 2. That does not simplify for me though, so I'm going to write out what I have. I have 1, 2, 3 x's. An index of 2 means I need a pair of x's to leave. So there's my pair of x's, so 1 x gets to leave, but I still have 1 x inside. My final piece is y squared, so we're going to do the square root of y squared. I can rewrite that as 2 divided by 2, which this one simplifies, right? It ends up being just 1, y to the power of 1. So I have my 3 pieces, right? I have this piece, I have this piece, and I have this piece. We have to put my 3 pieces together. And we do that by putting my outside pieces. So my 3 and my x get bunched together. Oh, and my y. That's not in a radical. And then what's under the radical gets pushed together. So our answer will be 3xy. And underneath my radical, I still have a 3x. All right, number 8. We have a fraction. It is both square roots, so we can keep going. So I'm going to divide and simplify each piece. 63 divided by 7 That is 9. X divided by nothing, so there's still an x, okay? Y cubed divided by y to the power of 1, I get to subtract. That becomes y squared. And this is all still in a square root. All right, I must split up the pieces, so I'm going to do square root of 9 first. Well, that's nice, because the square root of 9 is a perfect square, right? So square root of 27, the reason why I broke that up is because square root of 27 is not a whole number, okay? But if I do the square root of 9, that is a whole number. So I don't have to do all that breaking apart stuff. I can just say, oh, square root of 9, that is 3. All right, my next piece is the square root of x, okay? There's no way to simplify this because my exponent is 1, my index is 2, 1 over 2, like that means I need a pair of x's to take out of the radical, and that's impossible. I can't have any pair of x's, so there is just one x, and he's going to stay exactly where he is. There's no simplifying that piece. All right, the last one is we have the square root of y squared, which we happened in the problem before us. Remember that was saying we could do 2 over 1, which is just y to the power of 1. So the pieces we're going to put together is we have 3, we have the square root of x, and we have y. So 3 and y are on the outside, but x is still underneath my radical. Okay, so do it piece by piece. Okay, do just your constants, then just your x's, then just your y's, and then put your pieces together. Okay, moving on. All right, we have the cube root of negative 16 times the cube root of 4. They are both cube root, so I can move forward. I am going to multiply what's underneath my radicals together. So I'm going to put negative 16 times 4. Oops, helps if I type it in right. There we go. It gives me negative 64. I'm just going to show you what I did. So I actually multiplied together negative 16 and 4. So that gives me the cube root of negative 64. Okay. From the last lesson, we talked about how you can do an odd root of a negative number. So a cube root of a negative 64 is not a problem. Always type it in, see if it works. You might surprise yourself. So I'm going to go into my math menu, go down to cube root and negative 64, and it does equal negative 4. So this just equals negative 4. That's it. That's my answer. That's how it's simplified. Okay, because I got a perfect cube. Okay, number 10, we have the square root of 18, k to the 9th. All right, I'm going to split them up. So let's deal with the square root of 18 first. Okay, square root of 18 is the square root. If you're not sure, type it out. I know it's not, but I'm going to prove it to you. The square root of 18 is a decimal. Okay, we don't keep answers in decimal form, we keep them in radical form. So, since that's not going to work, let's break it apart. What times what is 18? Well, we have 9 and we have 2, right? Break apart 9 again. That's 3 times 3 times 2. Remember, this is technically a square root, so I need a pair of numbers to leave. I just got a pair of 3's. So 3's get to leave, but I still have a square root of 2. Okay, it didn't have a pair of 2's. Now I'm going to simplify the k piece. So I have k to the power of 9. So square root of k to the power of 9. I could rewrite that as 9 over 2. The issue with that is it's not a whole number. Okay, so I'm going to write out my 9 case. Ready? 1, 2, 3, 4, 5, 6, 7, 8, 9. There we go. Our index is 2, so we're looking for pairs. Here's a pair. It gets to come out. Here's another pair that gets to leave. There's a pair, and then there's my last pair. So we actually had 4 pairs of k's, right, with 1 left over. So that means we have k to the power of 4 on the outside, but we still have 1 k inside. So the pieces we have to put together is 3 times the square root of 2, and k to the 4th times the square root of k. Pieces on the outside are 3k to the 4th. Pieces on the inside are 2 and k. So 3k to the 4th times the square root of 2k. All right, moving on. Number 11, we have the square root of 12x squared y times the square root of 3xy to the 4th. They are both square roots, so we can move forward with this problem. I'm going to multiply what I have, so 12 times 3, I'm going to keep going. 12 times 3 is 36. X squared times x to the power of 1 is going to be x cubed. Y to the power of 1 times y to the power of 4 becomes y to the power of 5. Okay, these are all square roots, so if you want to put your index of 2 out there, you can. Let's split them up piece by piece. My first piece is the square root of 36. We like that because the square root of 36, that's a perfect number. Again, always check before you start going into all the work of breaking it down. If it's a perfect square, you don't have to do all that. Square root of 36 is 6. So that is equal to 6. I'm done with the number. Okay, let's move on to my x's. The square root of x cubed is saying x to the power of 3 over 2. Doesn't simplify. So 1, 2, I have 3 x's underneath my square root. Index of 2 means I need a pair, right? So I have a pair of x that comes out, but I have 1 x left over. Last thing to simplify is y to the 5th. So we're going to have square root of y to the 5th, which is going to be y to the power of 5 over 2. 5 over 2 does not simplify, so I'm going to write out what I have. 1, 2, 3, 4, 5 y's. Index of 2 means I need a pair, so there's a pair of y's. Here's another pair of y's, but I do have 1 y still inside. So this simplifies to y squared with 1 y inside. We got my pieces. So my constant is 6. The variable with x has an x on the outside, x on the inside. And then my variable y has a y squared on the outside and a y on the inside. So 6xy squared on the outside, and then a square root of x and y. Okay. Number 12. With number 12, now we have a coefficient outside of our square roots. So we have 7 times the square root of 3y squared, and we have 2 times the square root of 6x cubed y. So again, they're both square roots. That's what we look for first, so I can put this all together. So 7 times 2 gives me 14. It stays on the outside. That's where they are. Now I'm going to do 3 times 6, which is 18. Y squared times y to the power of 1 is going to give me y to the power of 3. And then I do have x cubed. All right, this 14 on the outside is just going to stay there. There's no simplifying it because 14 is just 14. The square root of 18 does simplify. We actually did it on number 10. Okay, so I know that it's going to go ahead and simplify. I'm going to keep 14 here. In a previous problem, we figured out that the square root of 18 was equal to 3 square root 2. So if you're not sure how that came about, go back to number 10. Okay. Y cubed has also already been done, right? What was y cubed? Well, I know we've done x cubed, right? X cubed happened in the problem right before us. So if we have y cubed, let me change this. The square root of that, I can't do it. So that means I have 3 y's, 1, 2, 3. A pair of y's does come out with 1 y left inside. The same thing is going to happen for my x cubed, right? The square root of x cubed. I did do that in the previous problem. We know that equals x to the times the square root of x. Okay? So my pieces are 14, 3 square root 2, y square root y, and x square root x. This time we have 4 different pieces to put together, okay? Whatever is not under a radical gets put together. So we have 14 times 3 times y times x, okay? 14 times 3 is 42, and then we have xy. Under my radical, we still have an x and we still have a y, so those get written together. So, oh, and we have a 2. 2xy are also underneath the radical. Okay, this 42 came from 14 times 3. Okay. Now we're going to go into rationalizing the denominator. Okay, so to rationalize the denominator is when I can't simplify the fraction. So notice now I only have one piece of my fraction that has a radical on it. So here we have the cube root of 3 underneath as a denominator. That's not allowed to stay that way. We can't have radicals in denominators, so this is why we rationalize it, okay? So we got to think, what's going to make that radical go away? Well, all the other problems I was doing, remember, things came out in numbers of the root. So here, I'm going to need 3 of the same number for something to leave the radical. I only have 1 3 right now. So in order for that 3 to get removed, I need 2 more. Right? So if I have square root of 3, cube root of 3 and cube root of 3, right? Now I have 3 cube root 3s. That means I can actually cancel them out because that becomes the cube root of 3 times 3 times 3. Index means I need 3 of them. I have 3 of them, so my denominator becomes just 3. Okay? That number on the outside tells you how many of those you need to have. I need 3 cube root 3s. I only have 1. I need to put 2 more. Okay? Now, if I do something to my denominator, I got to also do it to my numerator. Okay? So I have to multiply it to the top also. Okay, so what does that leave me with? It leaves me with the 2 on the outside. Those are the same thing, so I can simplify that to the cube root of 9. There is no simplifying anymore, so that just stays 2 cube root 9. If 2 and 3 were able to simplify, I would. But for this problem, I can't, so it stays that way. And I can't simplify the cube root of 9 anymore. Okay, 14. I have a cube root of 2. So what does that mean? It means I need 3 of the cube root of 2's, right? I only have 1 of them. I need 2 more. So I need to multiply 2 more of them in here. Okay, if I do it to one piece, I got to do it to the other piece of my fraction. So my denominator is now the cube root of 2 times 2 times 2. I need a group of 3. I gave myself a group of 3. So the 2 gets to leave the radical. That's why we do it. Okay, so that way the radical itself gets canceled out. I have to simplify my numerator. Here, this is going to be a 6, right? This becomes the cube root of 4. I cannot simplify the cube root of 4. There's not 3 of the same number that can come out of it, so it's going to stay 6 cube root 4. But 6 divided by 2, the numbers on the outside, that can simplify. So my answer here is going to be 3 times the cube root of 4, because 6 over 2 simplifies to just 3. Okay, those are like terms. They're not in a radical, so we're able to simplify those pieces. All right, we have 2 more. All right, 15, we have 7 divided by the cube root of 4x squared. Okay, so with this one, let's pay attention to what we have. That means I need 3 cube roots of 4s, and I need 3 x's, right? I already have an x, don't I? I already have one, so I'm going to kind of simplify this for you. So I need 2 more 4s, and I need 1 more x, right? Because doing that, and I'm doing this a little different this time, but pay attention. Now I have the cube root of, now I have 3 4s together, right? Here's 1, and there's 2 more. That gives me 4 to the power of 3. And now I have 3 x's, right? I had 2, I brought 1 in. So my cube root of 4 cubed is 4. Cube root of x cubed is x. That's why we do it. Okay, that little number tells you how many of that value you need. I needed 3 4s, I needed 3 x's. I had 1 4, I needed 2 more. I had 2 x's, I only needed 1 more. What I do to my denominator, I have to also do to my numerator. So the cube root of 4 squared times x. I'm going to simplify that. 4 squared is what, 16? This becomes 7 times the cube root of 16x. I'm checking with myself. Okay. All right, the cube root of 16 simplifies. Okay, the cube root of 16, I'm going to do it up here. So I can break apart 16 to be 8 times 2, right? The cube root of 16 is the same thing as 8 times 2. And 8 is a perfect cube. You should know that. The cube root of 8 is 2. And then cube root of 2 is still there. So 7 times 2, cube root of 2. So that's going to give me 14 times the cube root of 2, all being divided by 4x. And then last but not least, I know this is a lot, 14 over 4 simplifies to be 7 over 2. So that becomes 7 cube root 2x. Oh, there is an x. Sorry, there was an x there with my 16. Over 2x. The reason why the x's don't cancel is because one of them's in a radical and one of them's not. So I can't put those together. What I simplified was the 14 and the 4 because they were both outside of the radical symbol. All right, last one. 5x to the 4th y divided by 2x squared y cubed. They are both underneath a square root. So I'm going to move forward. When it comes to simplifying my fraction, let's look at this. Okay, 5 over 2 does not simplify. So that's just going to say 5 over 2, right? 4 minus 2 gives me a positive 2. So I have x squared in my numerator. And then here, exponents, 1 minus 3 gives me negative 2. So that means I actually have a y squared in my denominator. Because negative 2 means it belongs in the bottom. Okay, it was in, if I just had y to the power of negative 2, it's in the wrong spot. It needs to get dropped down. So this is my simplified radical. Okay, I have a square root. I need 2 of my denominator. So what's going to happen, I'm going to keep it separated like this. Okay, I need to multiply this by another 2. Okay, I don't need a y because I already have 2 y's, right? So all I have to do is multiply by the square root of 2. So my numerator is going to become the square root of 10x squared. And my denominator becomes the square root of 4y squared. Split them up. Square root of 10 does not simplify. Square root of x squared does. So I have an x on the outside, square root of 10 on the inside. Denominator, square root of 4 is 2. Square root of y squared is y. We wanted that to happen. That's what we needed to happen. Okay. There is nothing left to simplify, so that is my final answer. Because the pieces on the outside were x, 2, and y, and there's no simplifying. Okay. So I know this was a lot. You might need to watch it again. Or reach out to me and we can do some examples together one-on-one. This is your homework. Let me move. There we go. So it is page 731. Oh my gosh. 371. There it is. You are doing 17 through 31 odd. So we don't have to do this number 33 right here. Oh, well, let me go back. Okay. So 7 through 31 odd. So don't do that last piece. And then over here we have 37 through 49 odd. Okay. So 17 through 31 is all multiplying and simplifying. 37 through 49 is dividing and rationalizing. All right, so get those done. Let me know if you have any questions, and I'll see you next time. Bye.